Alright, I'm back. The hooded math teacher. I'm gonna get hot again and take it out. Anyway, it's cold up here. So I'm up here slaving in this room in the cold, trying to get y'all some notes for the whole week. You're welcome. Alright, we're going to talk about completing the square. Completing the square is another way to solve quadratic equations, and we also use completing the square to do something else. We'll talk about that something else later, but the way we're going to learn completing the square today is by using it to solve quadratic equations. And I got two versions of it here, and I'm probably not going to go slow enough for you to get these all down, but there's two versions here. And right off the bat, I need to remind you again of this: ax squared plus bx plus c. A, b, and c are all constants or numbers. Well, c is a constant. A and b are coefficients. And when I say a or when I say b, you need to know what I'm talking about. It's very important that you know which one I'm referring to whenever I say a, b, or c. All right, so this is how you do it when a equals 1. That means your coefficient here is 1. What you want to do is move the constant term to the other side. So in this way, you don't want c on the same side as everything. You divide b by 2, then square it. I'll show you that process in a second. Whatever you get, you add that number to both sides of the equation, and then you factor. Then take the square root of both sides like we've done before, and then you solve. And so I'll show you that here right now with example 1. So the first thing is, remember from the first time we took notes, is whenever you're solving a quadratic equation, you want that equal to 0. It doesn't matter which side your 0 is on this side, or I put equal 0 over there. It doesn't really matter. And so the idea says what you want to do first, or the rule says, you want to move your constant term to the other side. Okay? And so I have negative 11 equals x squared minus 8x, and I would usually leave a space there before I hit my equal sign. So if I rewrote it the other way, I would say x squared minus 8x equals, I just messed up my own thing, equals negative 11. I would leave a space right there, of which there is no space, but through the magic of TV, we have fixed our little boo-boo. And so if I was going to write it like this, initially, I would always leave a space whenever I'm completing a square. I would leave a space before the equal sign. Originally, I had it written like this. You don't have to switch it around like this, guys. It's okay to keep it either way. I'm just showing you both ways so you don't be confused. But keeping with this version here, the rule says after you do that, you take b, which in this case is negative 8, and you go off to the side of your paper and you write negative 8 divided by 2, and then you square that. That's going to equal negative 4, and negative 4 squared is 16. And so what you do with that number is you add that number to both sides of your equation, on this side and on this side. All right, I'm showing you what the instruction said. Now, what you want to do is simplify. Negative 11 plus 16 is 5. And what happens here is that this right here now you must factor. And this factors into x minus 4 times x minus 4. It's going to do that every single time. It's going to double up. It's going to be the same factor every time. But we don't want to write it like that. We want to write it like this. So technically, guys, you don't have to do this step if you understand that this is what you're going to get. All right? Now it says take the square root of both sides. All right? So I'm going to take the square root of this side, and over here, don't forget, is plus or minus the square root of 5. That doesn't simplify. And this is x minus 4. All right? Then we solve for x by adding 4 to both sides. So that's x equals 4 plus or minus the square root of 5. And if I ask you for a decimal, you would have to put it in a decimal form. It's not that much to it other than remembering the factoring part. Let's look at number 2. On number 2 here, notice that my b term is already on the other side of the equation, so I don't have to move it. So all I got to do is complete the square. X squared plus 2x equals 9. So I'm going to go off to the side of my paper and do 2 divided by 2. It's always divided by 2. Whatever b is, it's b over 2 squared, okay? And so that's a formula you might want to remember, b over 2 squared. All right, that's an important little formula there, but that's what I describe up there in the notes. That equals 1 squared, which equals 1. So what do I do with that? I add 1 to both sides of my equal sign. I put it in the empty space there. This automatically is going to factor into x plus 1 squared equals 10. And how do I know it's going to be x plus 1? Each time you do completing a square, if you simplify what's inside the parentheses first, it's always going to be that number in your parentheses squared. Same thing happened over here. That was a -4. Look what it turned out to be, x minus 4 inside my parentheses. Okay, but just in case you don't know that, this would have factored into x plus 1 times x plus 1. Then I would have wrote it like that. Either way, you get the same thing. Next, you take the square root of both sides and you get x plus 1 equals plus or minus square root of 10. You subtract 1 because you got to solve for x, and you get x equals -1 plus or minus the square root of 10. All right? Let's keep moving through a couple other examples. Usually completing a square kind of messes with people, so maybe the more I work them, and you may feel more comfortable. Now, in this problem, I'm just going to show you this just in case you don't understand. A is 1, B is 3, and C is -1. Okay? So that's where I'm getting A, B, and C if I need them. Now notice in this problem that B is an odd number. So far on the first two examples, if you look at them, B was an even number. And these are a little bit more complex because they have fractions in them. But I'm going to show you the process, and it's the same. You add 1 because you move your constant to the other side. That's x squared plus 3x equals 1. I go off to the side of my paper and I write b over 2 quantity squared. Now, does this simplify? Does 3 over 2 reduce? No, it stays a decimal. It stays a fraction and changes to a decimal. So I don't do anything to simplify. I just do 9 over 4 to raise it to the second power. That's 3 squared and 2 squared. So what do I do with that? I add 9 over 4 here, and I add 9 over 4 here. All right? So, how does this factor? X plus 3 over 2 quantity squared. Now, how did I get that? I told you every time you do this, and you simplify it inside the parentheses, and since this didn't simplify, I know automatically that that's what goes into here squared. In fact, I've seen some teachers do this. X plus whatever b over 2 was. Okay? b over 2 simplified goes right there, if you want to think about it like that. Alright? So don't let the fractions fool you. Now, all you got to do here is get your calculator. If you're scary or you don't remember how to do fractions, and you say 1 plus 9 over 4 equals 13 over 4. So I'm going to write 13 over 4. I prefer to keep it like that instead of a mixed number. Now, take the square root of both sides, and what you get, I'm going to write this over. You're going to have x plus 3 over 2 equals plus or minus the square root of 13 over 2. Where did I get 2 from? Because that's going to simplify. You can take the square root of 4. And if you don't believe me, hopefully my calculator will back me up on this. I can do 13 over 4. And it won't change it. But take my word for it. That simplifies to the square root of 13 over square root of 4. And the square root of 4 is 2. So that's how I get plus or minus square root of 13 over 2. Now, you subtract 3 over 2 from both sides. Run out of room, should have gave myself more room. And so this equals x. X equals -3 over 2 plus or minus the square root of 13 over 2. So this over here equals that. Another way that they write this is like this. -3 plus or minus square root of 13 over 2 since they have the same denominator. Either one of these are okay. Either one of those are saying the same thing. Now, this is one that's dealing with fractions, so it's a little bit complex. You don't have them that much. And how do you get those fractions? Whenever b is an odd number. So as you start learning these, maybe completing the square is one that you don't want to do if your middle term is odd. Just throwing it out there. All right, look at number 4. I'm at least try to get number 4 in here before we run out of time. But notice that this is the first one that we've worked where our leading coefficient is something other than 1. And so, if you remember, I gave you some steps here. And I'm going to go through this process. I hope you wrote them down. I'm going to go through this process and hopefully you understand. All right, same thing. Move the constant over. You have 7x squared minus 16x equals negative 100. But what you have to do here is, oh, this one's going to get sloppy. And I'm not going to have enough time to work this one out. So, okay, so hurrying up for time, I'm going to go ahead and work through it. This is math analysis, and so we need to be making sure we understand how to do the more complex math. All right, so we're going to run through it. When your leading coefficient is something other than 1, you got to factor that out just on this side. The problem is you can't factor out a 7 from a 16. This won't happen all the time, but if that's the case, then I have to put it over 7. That's a little math trick that you'll learn, and I'm showing it to you now. What did I just do? Well, if I multiply this times this, I'll get 7x squared. If I multiply this times this, I'll get 16 again. So you have to make it work. And yes, that's a rule. That's something you can do. You can add a denominator to it to make it work out when you multiply. Now you got to go off to the side and you got to do 16 over 7 divided by 2 quantity squared. And I'll use my calculator for this. I'll say 16 over 7 divided by 2. And when you do that, you get 8 over 7. And when you square that, you get 64 over 49. Okay, so I'm going to add 64 over 49 to both sides. Oops, no I'm not. Because whenever you have a leading coefficient number out here, you just don't automatically add to both sides. This is really 7 times that. So I'm not going to add 64 over 49. I'm going to say 64 over 49 divided by, times 7, and that equals 64 over 7. Why? Because this is really not just 64 over 49 because of that. So it's going to be plus 64 over 7, and you only do this again whenever you have a leading coefficient. Now, when you factor this down, remember whatever that is what it's going to be. This should be negative. Minus 8 over 7 quantity squared equals 64 over 7 minus 100, and you get negative 636. Yep, big number. Oh well. Divide both sides by 7. Why? You got to get rid of that 7. So you get x minus 8 over 7 equals negative 636 over 49. You put that in your calculator, it'd be over 49. Oops, forgot all that, didn't I? And so now you got to take the square root of both sides. And so now that equals x minus 8 over 7 equals negative, not negative, I'm going to call that I, 636 over 7. I did this. And when you simplify all of that, you'll get 8 over 7 2i square root of 159 over 7. That's plus or minus. And I'm running out of time, so I just had to skip through that. And I can show you that in class if you ask questions. And that'd be it.